Hi everyone, this is your struggling CS student and today I'll be doing another LeetCode problem. So let's take a look at today's problem. Alright, LeetCode 1014 best sightseeing pair. Oh, I've attempted this problem before, means I got cooked by this problem in the past. So let's see if I can solve it this time around. Not sure, I don't recall reading the editorial for this one, but we'll see how it goes. So you're given an integer array values where values of I represents the value of the I sightseeing spot. Okay, two sightseeing spots have a distance of j minus I between them. Okay, the score of a pair where I is less than j of sightseeing spots is values of I plus values of j plus I minus j. Okay, the sum of the values of the sightseeing spot minus the distance between them. Return the maximum score of a pair of sightseeing spots. Okay, 0 equals to 2, 8 plus 5 minus plus 0 minus 2. Okay, we always have two values and it's up to 5,000. Okay, values of I is only positive. Okay, all right. So how will we solve this problem? The trick is, not sure if it's a trick, but when I was learning about the data structures and algorithms about solving LeetCode problems in general, usually when you have to query for the next element based on some sort of criteria. So, for example, in this case, then it hints towards using a monotonic queue or monotonic stack because it allows us to basically for each element query for the next element that query on the next element based on some sort of criteria. So in this case, what we want is the maximum score of a pair of sightseeing spots. Now, a monotonic stack and a monotonic queue comes to mind, but I do not know how to use them yet at the moment. So we'll see how it goes. I could be wrong, by the way. Could be like way off. Well, okay, what's the brute force approach? The brute force approach would be, for every pair you check against, for every number you check against every other number, and then you just compute the max and just return the answer, right? But given that the values dot length is 5,000, n square solution most likely will not pass, and I couldn't solve it the first time around, so I'm thinking towards a monotonic queue or monotonic stack, but how would that help us? Let's use this example. Let's go through a few examples, see how it helps us. So 8, 1, 5, 2, 6. So this is the indices, 3, 4. So we know that actually what? That this is the answer, right? So it's 8 plus 5 plus 0 minus 2, which is 11 in this case. Okay. Let's say we build the monotonic stack in this manner. Should it be decreasing or increasing? Let's say it's decreasing. Is 6, 2. 6, 2. You pop this, and it's 5, 1. And afterwards, you pop this all the way until here. Then the maximum score of a pair of sightseeing spots. So at this point, We can always calculate the score for this, score for this, score for this, score for this. When we calculate the score for this, yeah, maybe it's not monotonic stacks are Q. If it's increasing 6, 2, and 5, 6, 5, 1, 8. Increasing 6, 8. I'm thinking if there's a DP component to it. DP component. What does this mean? We can either choose this as one of the spots or not. So if we choose this as one of the spots, then we want to break the subproblem down into this. And what do we want to say? We want to say what's the best spot. Okay, let's see what's the if the problem is just like this, then what's the max here? The max here is probably this plus this. All right. So there'll be 0, 1, 2, 3, right? So 5 plus 6 plus 1 minus 3. That would be 11, 12 minus 3, that would be 9, right? So that's 11, that's 12 minus 3, yep, that's 9. Okay. How would that help us at this stage? Is it DP? Is it DP? Okay, I'm stuck already. Oh my god, I'm gonna cook by the same problem again. Right, let's take a look. Let's think about this.
20 minutes later.
Decreasing stack by both sides. For I range of n, and it's crystal line of values. Just an intuition, which, yeah, probably not the best. Values of as -1. We are doing decreasing. What if it's values are, what if this was 6? What if this was 6? Yeah, you could calculate them. You should calculate them. Less than values of I. That's not top. And we'll get the index. Now, pen I. Return best. Okay. You have this index that we just pop. What does this mean? Going from left to right, that means best is max of best of I minus index. And values of, this one doesn't really matter, index plus, so we know actually this is I and this is J, so this is I and this is J, sorry, this is I, this is J. Okay, then go the other way around. Clear this, n minus 1, minus 1, minus 1. So, and I, this time around, is this J, best of, this means what? That means this is I, this is index, is I minus index. Okay, why the fuck does this work? Skin some more random values. Does it actually work? Why the fuck does this work? Okay, I'm going to try to convince myself. How does this work? It's just an intuition, but I don't know why this works. Now that's a problem. It's a problem in my learning because there's no knurling. I just, based on experience, seen this type of problems before. There are only so many ways you can solve them, and this is one way to solve them where you just go through the array back and forth. But there's some sort of key observation here that I'm missing, and I don't know what that is, and it annoys me. So I'm not even sure if this is the actual solution, but yeah. Let's say I do 10, 20, and there's some filler values in between. Doesn't really matter. Let's do 3, 4. Okay. Okay. Let's use the same example here. Decreasing here and then decreasing here, right? This means what? Decreasing here. We have 8, 1, no, and then 5. So at this point, when we are popping off this, we are calculating an answer for this. Why is that? Why do we calculate the answer for this? Okay, fuck it. Let's move on first. All right. So we calculated the answer for this pair. Let's just mark it in red. Then you put 2. You put 2, then you put 6. Okay. Then now you calculate the answer for this pair. This pair, which is 2, 6. Then you calculate the answer for this pair, which is like this. And then it's like this. Now you go the other way around. You go the other way around, which is you have 6. Then you have 2, then you have 5. Now we calculate the answer for this 2. Put it here, delete this. So you calculate this and this. Then you put 1 here, 1 here, then you put 8 here. Then you calculate the answer for this 2. Then you calculate the answer for this and this. Then you calculate the answer. You actually don't calculate the answer for this, but you do. I don't know what I'm talking about. Because this is decreasing, then at the end of the day, this will destroy, overwrite, and overwrite. Okay, so I calculate the answer for this as well. Calculate the answer for this, and calculate the answer for this. Okay. Okay. So why does this work? look at the comparisons for this guy. Let's look at the comparisons for this guy. For this guy, we compare with this element in this comparison, compare with this element for this comparison. We also compare with this element for this comparison, right? Thing to notice is we actually never compare with this element ever. And why is that? Is there no reason to ever calculate for this? So you take, so let's mark your indices like this, 0, 1, 2, 3, 4. Then here, the score for this and this is 8 plus 2 plus 0 minus 3. That would be 10 minus 3, which is 7. Okay, so between this pair and this pair, the score is 7. 7. But of course, we would just compare with this, right? We would just compare with this. Like, it's better to just compare with this. And if there's a smaller number here, let's say if this is 1, it's, no, if this is a smaller number, we will also check. We will not check this when we have a bigger number. Oh, I see, okay. Okay, I kind of get the intuition. I see. That's why you want a decreasing stack. You want a decreasing stack. Basically, you want a decreasing stack because for this particular element, right? For this particular element, how should I explain this? Let's say you have A, B, C, D. Well, this would be the best case, right? The best case is, suppose this set of numbers are sorted, then every time you go to the right, you would take the value of this and you subtract the difference between this and this, as in the distance between them. But the thing is, you will never ever consider an element where it's kind of like smaller than its neighbors for a particular element, right? So what I mean to say is, let's say if you have a 10 here and you have an 8 here and then you have a 6 here, you would just rather consider this, and you will never actually consider this. That's why you want a decreasing stack from the right. What if they're all equal? What if they're all equal? Let's do 6 and 4, 4, 4, 4. Okay, that also passes. Fine, fair enough. What if they are one off? So if they're 9 and this is 8 and this is 7, let's do this case, right? Let's do this case. So forget about all this, and the index are 0, 1, 2, 3. This means that if it's decreasing, then it's 9, this is 8, this is 8, or this is 7, this is 8. Then compare this with this. Yep, okay. Now at this point, the score for this is 18 minus 1, which is 17. The score for this is actually 17 minus 2, which is what? Which is 15. So there's no point comparing with this element. You just want to compare. Oh, okay, I see. What about this guy? This guy, that would be 19 minus 3, which is 16. What if this was an 8? This was an 8, then this would be 18. This should be 18. Oh, that's why you use equals. I see. I'm pretty sure if you take this out, it wouldn't work. It still works? Oh shit. Okay. Okay. YOLO submit. Okay. A solve is a solve. I actually don't think this will work, does it? Yeah, okay. That's what I thought. Alright. I can't explain this very well, but at least I hope the intuition is correct, I guess. Dynamic programming? Oh my god. I was thinking of that. I com what? Is that really a monotonic? Wait, what? Really? What the fuck? I accidentally solved this problem and the solution is not even in the editorial. Okay. But let's see how they do it. Let's see how they do it, okay? You should really go to bottom-up approach. Interesting. Huh. Um, DP. Okay, let's see how. Wait, DP. ON? ON? What the hell? Okay, I need to read this when I need to read this in my free time, but I don't know how the fuck I solve this problem, but hey, it's a solve is a solve. I don't really like it because I can't explain it well. I'm gonna watch some YouTube videos explaining how to solve this problem. But anyway, thanks for watching. This has been a long one. I'll definitely cut it short. And yeah, thanks and have a nice day ahead, man.